In this example, we are going to override the str method for the class student and for the BSc student and PhD student classes that derive from it. And we're going to see how this redefinition of the str method interplays with inheritance. So, because this involves some code, actually, I have included these three classes a bit rewritten in the students.py file. And if you click on this cell, you run this cell, that's going to generate a link to the file that you can click, and it's going to open the file in your text editor, especially if you're working locally. Otherwise, if you're on the Jupyter Hub or you prefer anyway to use Jupyter Notebooks to open that file, you can just click on the directory page and you can directly open student.py here, and that's the file. So let's have a look at it in detail. Actually, I would suggest that you stop this video now and you take the time to go over this file at your own pace, and then you start this video again. So if you've taken the time to read through this, you will realize that I've actually introduced three new methods, and those are the str methods for the three classes: for student, for BSc student, and for PhD student over here. Now the str method for student just gives us some information about the student object. So quick recap, the str method needs to return a string, and this string is the string that's printed when you try to print the object, for instance by printing fresher. Or this particular implementation of the method constructs a string that's built this way: the literal string name plus the name of a student plus a space plus the surname of a student, a new line, and then their print credit. This is actually a bug. There needs to be an underscore there. So far so good, this is easy. Now the BSc student class, because it extends student, inherits the str method from it. But instead of being happy with that, we decide to override it inside this class. That is to say, we decide to redefine it. And we choose to implement it so that it prints some more information. So again, we have the name of the student, the surname, the print credit, but we also print whether the student likes beer or does not like beer. And again, all this information is assembled inside string s, which is then returned by this method, and that's what will be printed when we try to print an object of this type. We've done the same thing here in the PhD student class, which is also extending the student class. But in this case, instead of starting from scratch and just, rebuilding the string, which is anyway defined by the str method of a class student, we decide to use this method to get us started and to build this basic boilerplate information. So there it is. We start with s equals student.str self. So this basically is calling the superclass method. And then we check whether the PhD student has published. If he has published, we add as published safe, and otherwise we add will perish, and we return this string. Or just a quick note, instead of naming the superclass explicitly, we could have used the keyword super to identify the superclass. Okay, So these are the changes to the three classes. We have redefined the str method in each of them. We're now ready to return to the notebook and see how this works. So back to the main notebook. The first thing we want to do is we want to import the class definitions from that students module. And we do that with an import statement. We rename the module as st for convenience. And now we create our students, but this time using the classes from the module. So standard equal st.student John Smith, fresher is st.bsc student Ethan O, and nerd is the st.phd student line type. Now, if you try printing these three objects, you will see that each one calls a different str function to build its printed representation. So this is the function that we defined for the standard student. The one for the BSc student would add information at print credit and on whether they like beer, and the one on the PhD student would add print credit and whether they've published or not. So what this shows you is that if you're not happy with some functionality, so for instance, you say you buy this standard class student, this base class from an external provider, and you're not happy with some of their functionality, you can actually overwrite it in your derived classes, and you can change the behavior the way you like. But there's more to it than just that, because we can try and rewrite the code this way. So we can have a collection, all hands, that includes the standard student, the fresh, and the nerd, and then we can loop over this collection, and we can have a variable going over that. So that variable is going to become each of them in turn, and we can call print, which is going to call the function chap.str, and see what happens. That's it. That's the same function is this function that gets called each time, once for each of these people. But each time it does something different. Why that? Because each object knows what type it is, and it knows, therefore, what actual code to call for that function. And this is called polymorphism. And as you see, it's an incredibly convenient way of doing things. Now, if you go back to the top of this notebook and you read again the example that we put in the introduction, it should make a lot more sense.